From Cambridge University Press, in collaboration with The Naked Scientists, this is episode 1 of the Cambridge Prisms podcast, addressing real-world challenges in research and discovery. I'm Chris Smith. This month, should we be sequencing the genetic code of every human newborn? Apparently, we're in the midst of the 6th mass extinction, but what were the other 5, and a clever way to conserve a species we know nearly nothing about. The Human Genome Project cost $2.7 billion and took 13 years to read all 3 billion genetic letters in the human DNA code. But since then, the molecular biological revolution that's swept the globe means that this feat can now be achieved for less than a 3-figure sum and in hours, not years. The result is that proposals are now springing up to unleash this technology as a screening tool for newborns. It sounds like a good idea, doesn't it? Let's bank everyone's DNA code at birth. But what does Annika Lucassen, Director of the Centre for Personalised Medicine at the University of Oxford, make of this?
Currently in the UK and many other countries, what's offered is a screening test when babies are usually sort of newborn, 5 days old. They get what's known as a heel prick test, and that looks for some very rare genetic conditions. And the proposals are to massively expand this heel prick test to look at the entire genetic sequence. We wanted to look at some of the issues that raises.
As one person put it to me once, with genetics, you get the answer to the question you ask. So if we just screen the genomes of hundreds of thousands of newborns, all we'll know is their genetic code. We won't know anything about outcomes yet, will we?
Yeah, I like that quote. You get the answer to the question you ask. And I think that's really interesting because, of course, when you read about genetics in the media, newspapers, or even sort of just listening to people's understanding of genetics, we hear a lot about people saying, well, it's in my DNA. People tend to think that genetics is really clear-cut. You'll be able to look at your genetic code and make clear predictions from it. But you are absolutely right. All we can really do is look at the sequence and interpreting what that means for good or ill health is a much more complicated, nuanced step.
One of the criteria for doing screening for anything is that we only screen for things that we think we can do something about. But I suppose inevitably when one reads the genetic code, you're suddenly armed with all the knowledge and you don't know what you do know and what you don't know at this stage. So are we screening for things we can't do anything about, therefore?
Yeah, that's another really interesting question. I mean, some people would say that making reproductive choices, so deciding whether or not to have children or testing in early pregnancy, might be something that can be done about it that means that a diagnosis is helpful, even if that diagnosis itself isn't treatable by medication, for example. So that question that you so rightly raise of, is there an intervention we can offer, is again more complicated than we first thought. It's not just about, is there a tablet I can take if I diagnose this? Do people want to know this to make future decisions? And that, of course, varies from person to person. So I think it's much harder than people thought to say, is it worth screening for this particular condition or not? We can make generalizations, and we might say, actually, screening babies for adult onset conditions is probably not a good idea because there's nothing that you're going to be able to do in the next 20, 30 years. But even then, some parents will say, well, that will be useful for me to know so I can guide how I bring my children up.
What do you think the really big problems that we're going to have to confront around this are then?
There's loads of big problems, but let's focus just on the newborn screening. The biggest problem is that it's been proposed to end diagnostic odyssey. So a diagnostic odyssey is something that could be ended by sequencing our entire genetic code or genome, because many of the people diagnosed by whole genome sequencing had many investigations before then. And this cut short those investigations. The problem in newborn screening is that you might be starting people on diagnostic odysseys rather than ending them, because you're starting with a healthy baby and your ability to predict what the genetic code means in them is much, much poorer than starting with someone with particular signs and symptoms where you're using the genetic code to make that diagnosis. So I think the starting of a diagnostic odyssey and the consequences that has for the NHS of needing to follow up lots of children or otherwise healthy babies for a long time to see whether a variant really means what we think it does, they haven't really been factored into the equation at all yet.
Do you have any kind of solutions to this, or to your mind, how should we go forward? It's a good idea to learn about the genome. It's a good idea to be able to marry up what's in our genomes with what our eventual disease outcomes are, because we can then begin to unite cause and effect. But how should we be going forward on this?
Well, I'd say cautiously. So I think, is it a good idea? Asking that question, is it a good idea? And in what circumstances is it a good idea? I'm not at all convinced it is a good idea to offer this to healthy newborns. I think it would be much more effective, particularly at a time that the NHS is in crisis already, be much more effective to offer whole genome sequencing to ill newborns. It's very effective there. But I think to jump from saying we can do it technically to we must do it is a jump too far for me.
Annika Lucassen there. Over the last 500 million years, during which complex multicellular life has existed on Earth, there have been periodic extinction events where up to 90% of all life forms died off. Some say we're in the midst of another one now. So what do we know about these episodes, and how often did they happen? Charles Marshall is a paleobiologist at UC Berkeley.
Over the last decades, there has been a sense that there are 5 big mass extinctions. They're known affectionately as the Big Five. And what I really wanted to do is find out whether they really are a thing and just what are their properties. Do they have things in common? Do they have things that are quite different from each other? Related to that, the Big Five have become canonized in popular parlance with the notion that the current biodiversity crisis is called the 6th mass extinction, making reference to those 5. So there's relevance to that issue as well.
So in that regard, how did you actually approach this then to test the validity of this claim?
So mostly it consisted of just systematically going back and reading all the papers that were relevant, the initial proposal of the Big Five, and the methods and quantitative tools that were used to identify them and even define what a mass extinction was.
And how far back in time are we talking here with the Big Five?
The Earth's about 4.5 billion years old. And then starting about 540 million years ago, we start to see a rich fossil record. And that's when we can start to measure origination and extinction, evolution in the fossil record well. And so we're talking really about the last 540 million years. And in that interval, the Big Five mass extinctions have been identified.
And if we look at other things that are going on at the same time, and we look at other records, other sorts of measures of what the climate was doing, how the planet was behaving, how the biosphere was behaving, are there any clues as to why we got extinctions on a mass scale when we did?
That's a tricky question. One thing that is clear that the mechanisms of extinction are different for each. So the end Cretaceous 66 million years ago, many, but not all, would agree that a giant meteorite the size of Mount Everest slammed into the Earth, causing short-term intense climate change. The biggest mass extinction that everybody agrees upon is the end Permian, about 250 million years ago, before the dinosaurs, before the rise of mammals. And that seems to be a longer period of extended volcanism that would have flooded the lower 48 states of the United States to the height of Sears Tower in Chicago. Massive outpouring of basalt that caused long-term climate change. The end Ordovician, which is the first one, looks like it was related to a major glaciation event that perhaps drained shallow oceans off the continents where a lot of life was. Today's world is strange in that the continents sit mostly high and dry, but for much of Earth history, the continents have been flooded with very, very shallow oceans, which have been replete with marine life.
When one looks for evidence of these mass extinction events, are we just seeing what we've got in the fossil record and saying, well, there's a lot there, then when we look a bit later, there's not so many? Is that reliable? Do we know that they genuinely were big die-offs, or could it just be a sampling error?
That's a very good question. In many ways, the idea of mass extinctions didn't take proper hold until the end Cretaceous meteorite impact theory came along, because it was very unclear, one, what the duration was, and then the second one, which you stated explicitly, is the incompleteness of the fossil record. And now it appears, in fact, that I might have the oldest fossil and then the youngest fossil of a species, but the time of extinction may post-date that youngest fossil by tens, hundreds of thousands of years, maybe 500,000 years. So there's a great deal of uncertainty as to when things actually became extinct and whether or not they became extinct simultaneously or not.
And do we have an idea as to how many species or what fraction of species were lost in these mass extinctions?
So it varies. The higher estimates are in the order of 90% of species, but that's the biggest of all. And there's a continuity of extinction intensities, a little bit like there's a continuity of earthquake intensities. And the intensity of extinction we see in the fossil record runs up to the order of 90% and all the way down to just a few percent. So there's a continuity of extinction intensity.
And how about today? Because that's the critical thing, isn't it? People are very concerned about environmental degradation and so on, loss of species now. How does the trajectory of loss today compare with some of these historical events?
That's a very tricky and interesting question. The mass extinctions in the fossil record were identified primarily by the magnitude. In comparison to those numbers, we aren't even close to a mass extinction yet. Relatively few things have actually gone extinct at our hands, which is fantastically good news. What is disturbing is that all the other ones are large-scale interactive effects, where this one is caused by one species and one species alone, us, and the rate of disappearance of species already is far higher than all of the mass extinctions except for the end Cretaceous mass extinction with the meteorite impact. So if we do nothing, I'm pretty sure we will be in a mass extinction, but we're not there yet. So I've proposed that we call the sixth mass extinction something quite different. I don't like the number 6, and it hasn't happened yet. So I like to call it the incipient Anthropocene, identifying us as humans as the cause of it, mass extinction to evoke those big extinction events that we do see in the fossil record.
Thought-provoking stuff. Charles Marshall there. This is the Cambridge Prisms podcast, reviewing some of the cutting-edge science from Cambridge University Press's Prisms suite of journals. Still to come, how do you conserve an endangered species that you know almost nothing about? Before that, though, coastal communities, indigenous peoples and small-scale fishers are intimately connected with the ocean. Yet these historically and structurally marginalised groups often bear a disproportionate distribution of coastal and marine harms and are culturally and politically excluded from marine decision-making. Those are the words of Jessica Blythe of Brock University in Canada in her paper on what's dubbed Blue Justice and how these communities are pushing back.
In a nutshell, this manuscript is trying to tell, I think, a David and Goliath story, which is about marginalized coastal communities who are standing up to big business or governments or other organizations when they're being disproportionately exposed to harms.
Which harms and which nations?
The harms come in many forms, and one of the things we argue in our paper is we need to expand the lens that we are looking through to see what coastal communities are experiencing. Coastal communities are often exposed to hazardous waste, inequitable resource extraction harms, and also ocean grabbing or displacement in the name of usually development or economic growth.
And on what sort of scale is this happening?
from local to global scales in every country in the world, but often along lines of economic inequality. So often harms are going from wealthy nations to low-income nations or low-income communities and populations.
So it's a bit like Western countries exporting all of their manufacturing of nasty stuff to other countries and then saying, look, we've been very virtuous and we've cut our carbon footprint and our pollution footprint. All we've done is swept it under the carpet geographically.
Exactly right. And there's some really horrifying examples in our paper of hazardous waste from the United States going to Haiti, or from oil refining hazardous waste going from Europe to countries in Africa. So absolutely.
What do you advocate that we can do then?
One of the most exciting things about this paper is it's really a story about solutions and about possibilities. And what we argue through a review of all these amazing cases is coastal communities already know what to do. They're already fighting back, resisting, preventing these kind of harmful projects. But not only that, they're also proposing solutions and alternative ways forward that are both healthier for the environment and better for those communities.
Can you give us some examples?
Yeah, absolutely. So one really exciting one happening here in Canada is the revival of an ancient First Nations practice called clam gardening. They're building up little areas of the coast with essentially rock fences, and that keeps clam populations inside those. And the tide comes in and floods those areas, and it causes a higher concentration of clams, which can be harvested for food. They also are good at preventing erosion from big storms, so also a climate adaptation. And they're helping to revitalize Indigenous management practices, culture, traditions. So that's a really exciting example of a solution.
Is your point then that if people are more autonomous and they also are more engaged with their environment, they're less likely to be susceptible to the charms of big business because they can pay their own way rather than thinking, I have a choice to make. Do I eat today or do I take their dollar?
Yes, absolutely. And I think that's one of the most exciting parts of this project is it's not an either or situation, but it's a both and situation where the kinds of solutions that communities are proposing are successful at resisting environmental harms, but they're also economically better for communities. They keep more resource access locally rather than being exported. They're better for social well-being and cohesion amongst communities because they're often revitalizing community networks and practices that were in place. Yes.
It sounds a bit like a kind of what's not to like. Comment is needed from me here, but why is this just not happening anyway then?
Yeah, that's a really good question. That might be the most important question. One of the things that we argue in our paper is that these stories just aren't being heard widely enough. And so we argue that one of the roles of academics potentially is to help bring these stories to the broader public so that they can be used as little pilot studies that can be scaled or learned from. So I don't think there's a problem with the community's responses. I think there's a problem of communicating them and making sure that they can learn from one another.
So you're saying that there are some really bloody good ideas out there being implemented perhaps on a small scale in some places, and because people in those other places that could do the same don't implement them because they don't know about them, or people who could fund the implementation don't know about them, they're not happening.
Yeah, absolutely. And I think there's a feeling of being the underdog or it being not possible to resist these big forces that are very wealthy and very well entrenched in our economic systems and our political systems. So I believe that one of the benefits of sharing these stories is not only to learn ideas, because each community requires a contextualized solution, but also to build this feeling of possibility. These solutions are possible and they are happening. The fact that they're happening at all, I think, is not well enough known.
Won't the big businesses just up their game?
Yes, potentially, but I guess I'm an advocate for collective action and social movements, and we have lots of examples historically of those movements being very effective at taking down, what I would characterize as these Goliath big business. And I think that is happening. And so part of our job is to help work with those communities and with these movements to push back against those big forces.
Jessica Blythe there. Conservationists rightly argue that we can't preserve and aid the recovery of species that we don't understand. But if time's not on our side, which often it isn't, we might not be able to learn enough about that species before it's already too late. So can we short-circuit the process? Well, Anderson Feijo, based at the Institute of Zoology at Beijing's Chinese Academy of Science, thinks so. He's come up with a way to use what we do know about a rare species, in this case an endangered Brazilian armadillo, to spot patterns that can be used to identify other relevant literature and studies on other species that nevertheless provide insights into how the target species behaves and where else it might be found. It means they've been able to find more populations of these animals and spot some of the key factors that seem to be critical for their survival or can hasten their demise.
We use as a subject one of the most threatened species of armadillo in the world, and the only armadillo that is endemic to Brazil, only found in Brazil. This species is very, very rare and can only be found in a specific kind of habitat in the northeast in Brazil. And because of that, there is very few data about this species, but we do know that it is highly threatened with about 70% of the population already gone. So we do need to find a ways to prioritize the research, the conservation in key areas for the species conservation.
People often say that you can't possibly hope to conserve something if you don't understand it. So I guess part and parcel of this work is understanding a rare species and a poorly studied species, so you can understand why the population has dropped so dramatically and therefore how to prop it up and make sure we don't lose the remaining 30%.
Absolutely. At this moment, we know so little about the biology of these species, but we also know that if you are waiting to get all the information we need, by the time we got this acknowledgement, the situation might be too critical for the species. We basically only know where the animals has been found. So the information about the biology of the species, what they eat, what specifically of habitat they can live or sleep or reproduction, we basically know nothing about this species. But we do have where this species has been found. So we use those points that the species has been found in different geographical range of the species and combine a different set of methods to identify other potential areas that we could find the species based on similarity of the climate, the habitat, the vegetation where the species are currently present. We also use land cover information, that is the information about the habitat. If the area the species was found is a farm or is a savanna, is a forest, what kind of habitat those individuals were found. So with that very simple information, we're able to explore different methods available nowadays to give us a better understanding of the overall requirements that species need to survive.
That's quite clever. So basically, by knowing where they tend to be and where they've disappeared from and asking what do we know about those areas already, you can make inferences about what's probably important to this understudied species.
Precisely. We did have information of the previous locality where the species were found, but nowadays are considered extinct. And we did have information about where the species is currently present. So we were able to detect that all the recent population are mainly found in areas that still has natural vegetation, while those population that went extinct are mainly found in areas that now is covered by farms or cities that has grown in the last 35 years. So that was actually a very important study and result because allow us to emphasize that natural areas for these particular species is critical for their survival. If we lose the remaining of natural area, it's probably that we're going to lose these species altogether.
What was the volume of data like? Was there a lot to work with when you're making these sorts of inferences based on work that other people have done on other animals and other environments, which you can then apply to the armadillo? Was the data of a good enough quality, and was there enough of it?
Yeah, we spent a quite good time to gather as much as data as we could. Part of the idea of this project was also to revisit some of the areas we knew the species were once found, but has been long time not recorded. So we contacted several researchers that work in the same area the species were once found and start to ask if they were able to found this species, because in areas where the species occur, actually it's not very hard to find it. Because of that, we're able to find more than 20 new populations of these species, which was a very important increase from the previous data that report only 11 remaining populations. So we now know that there is about 30 population of these species across its distribution range. And with this more refined data, we then were able to run all of these new analysis with a more confidence.
And I suppose this is really valuable because it now can be used to highlight to policymakers, politicians and conservationists, these are the areas where we really need to preserve this environment, because it's not just this animal, this environment supports that animal, but it will also support all these other animals that we know also go along with that environment. So it gives you a much stronger argument, doesn't it, when you're trying to convince people to alter policy?
Definitely. And we use actually this argument in your own article, because we show that those areas that species are still present are also populated by other endangered species like the jaguar, the giant anteater, giant armadillos, cougar. So we show that those areas have something common that are valuable for several species. So if we can protect these species, will definitely positively affect many other species of mammals, reptiles, frogs. So that's why I believe these species can be a very good ambassador of this open area, the savanna area we have in Brazil, because it really tells a very clear story of if you do not preserve, the species are going extinctly very easily.
It's a great example of how meta-analysis is helping conservation efforts, isn't it? Anderson Feijo there. And that's where we have to leave it for this episode. You can join us again next time, though, to hear more cutting-edge science from Cambridge University Press, including the promise of personalised medicine. Is it hope or is it hype? And how we're trading species into oblivion. For the references and transcripts for any of the papers we've been hearing about this month, though, head over to nakedscientist.com/prisms, where you can also find out how to subscribe to this podcast if you don't already, so you can then stay in touch and get constant alerts on the latest articles. And if you've got some science to publish, why not submit it to the journals today? And then perhaps you can become our next guest here at the Cambridge Prisms podcast. I'm Chris Smith from The Naked Scientist. Thank you for listening, and until next time, goodbye.